So we're going to be finding the smallest value for this function, which is actually the last thing we do. The first thing we need to do is graph the constraints. So first, I'll just pretend that it's an equation, x minus 2y, and then set it equal to 4. And that's a line, so all I need to do is find 2 points in order to graph a line. So I could do something like x equals 0, which means this x is gone. And if you divide both sides by -2, then y equals -2. And then you could substitute that y equals 0, which means this term is gone. And that equation just says x equals 4. So we would have that as our table of values. And I think I'll go ahead and do the other one before I start drawing the graph. So for this one, just pretend that it says equals, so 3x plus 2y equals 12. And then make a table of values. And again, it's easiest to just use 0. So if x equals 0, this term is gone. Divide both sides by 2, and y equals 6. And then if the y equals 0, this term is gone, so divide both sides by 3, and x equals 4. And then we're ready to draw the graph. Also notice that it says x and y are positive, so we only need to look in the first quadrant. So if you make a graph, you only need the first quadrant, and then graph this point, so that would be y equals -2. Now that itself is not in the first quadrant, so basically I still have to use y equals -2, but then when I draw the line, I'm only going to pay attention to the part that's in the first quadrant. But I still need to use -2 to help me draw the line. And then this point says if x equals 4, let's say it's right about there, and then draw that line. So if I draw the line through there, starting at the -2, and then going this way, so that's the line, although I'm not going to pay attention to this bottom part down here, because we're only working in quadrant 1. On to the next point. So this one says y equals 6, so let's say that's right about here. And then, oh, this happens to be the same point. Nice. So that means it's going to be this line. Now pay attention to the inequalities. So I'm thinking that this is probably going to be the area, but I do need to test it. So literally it would be this whole triangle, although we're not going to use the negative part of it. So is this inside part of the triangle correct? So what I could do is test a point, especially if I have a red, and say test 0, 0. Is that the correct area? So if you go to this equation and you plug in 0 for x and 0 for y, the left side is going to say 0 is smaller than 4. So is 0 smaller than 4? That is true. And then if you use 0 and 0 for this one, it says 0 is bigger than 12. And that is not true, false. So basically that means that with this first line, it was true. And so the 0, 0 was true for this line right here, which means for the line that I just made red, then we need to be where 0, 0 is, so that's above it. And then for this line, which was this equation, that part was false, so it's not supposed to be below the blue one, it's supposed to be above the blue one. So in the end, if I get a nice highlighter, it's basically supposed to be all of this area here. And then with all of that area there, there's only 2 points to test. There's this one and this one. So this point right here is actually 4, 0. And this point right here is 0, 6. So we just need to test those 2 points. So if I have a little table with x and y, then the only points I need to test are when x is 4 and y is 0, and then when x is 0 and y is 6. And then finally, I need to go back and get the function. And that's what goes right here. So then plug in our 4 and 0. So if x is 4, that's going to be 4 squared times y is 0 minus 2 times x. So that equals -8. Then go to the next one and plug in that x is 0 and y is 6. And then that one would be 0 minus 0, so it's 0. And finally, what did I ask for, the minimum or the maximum? So I asked for the minimum or the smallest value. So the smallest out of a -8 and a 0 is actually the -8. So the minimum is p equals -8 at the point where x equals 4 and y equals 0.